Hello viewers, in today's session we are going to discuss one important problem from continuity and differentiability, right? So here we have a very important problem in which we have to discuss the continuity of the greatest integer function, right? And here we are given the function f of x is equal to greatest integer of x plus 2, and we have to examine the continuity of this function at this point x is equal to 2, right? So let us start. So viewers, we know that if we have a function say y is equal to f of x, then this function is said to be a continuous function at some point x is equal to a if the left hand limit at this point x is equal to a is equal to right hand limit, and both these limits are equal to the value of the function at this point, that is x is equal to a. So if this condition is satisfied by a function, that is the left hand limit is equal to right hand limit is equal to the value of the function at the particular point, then the function is said to be continuous at that point x is equal to a, right? And if any of the condition doesn't follow, then the function is said to be discontinuous. So here what we will do, we are given the point a as 2, and we'll find out the left hand limit, right hand limit, and the value of the function at this point, that is a is equal to 2, and we'll see whether this condition is satisfied by this function at this point a is equal to 2 or not. So let us first find out the left hand limit. So the notation for left hand limit is limit x tends to a, and here we put a negative sign, and here we have f of x, right? Now here we have this point x is equal to 2, which is x is equal to a is equal to 2, right? So the left hand limit is now limit x tends to 2 minus, then we have f of x, right? So now to calculate the left hand limit, what we will do, we'll take a point in the left neighborhood of x is equal to 2, right? So here we'll take a point, and this point is 2 minus h, so that this distance is h, right? And similarly, when we calculate the right hand limit, we'll take a point towards the right hand side of a is equal to 2, so that this distance is again h, and this point is 2 plus h, right? So all the points which lie towards the left of a is equal to 2 are less than 2, and all the points which lie towards the right of a is equal to 2 are greater than 2. So here to find out the left hand limit, we'll take x is equal to 2 minus h, and remember this quantity h is a very important quantity in differential calculus, because this quantity is infinitesimally very small, and it is a positive quantity, and h is greater than 0 and less than 1, right? So h is very small. So now we'll take x is equal to 2 minus h, and when x tends to 2, then h tends to 0. So the left hand limit is equal to limit h tends to 0. We'll convert this limit in terms of h, and here we have x is equal to 2 minus h, right? So now we have limit h tends to 0, and f of 2 minus h can be obtained by taking x is equal to 2 minus h. So here we have 2 minus h plus 2, and now we have limit h tends to 0, and here 2 plus 2 is 4, so we have a greatest integer of 4 minus h. So now we have to calculate this limit, and here we have limit h tends to 0, greatest integer of 4 minus h. So whenever we come across with functions like greatest integer of function, then we cannot substitute directly h is equal to 0, right? Because in some algebraic expressions, when we simplify the given expression, then at some stage we take the limit by taking h is equal to 0. But in this case, we cannot do so, right? So what we will do, we'll make use of the definition of greatest integer function. So the greatest integer function definition says that the greatest integer of x is equal to k, where k is some integer, z is the set of integer, right? So the greatest integer of x is equal to k if we have this condition, that is this x is greater than or equal to k but less than k plus 1, right? So here we have 4 minus h. Now remember, h is a positive quantity and it is very, very small. It is infinitesimally very small. So when we subtract h, a very small quantity, from 4, then this, so then 4 minus h is greater than 3, but it is less than 4, right? Because h is a very small quantity. So when we subtract h from 4, then 4 minus h is greater than 3, but it is less than 4. So from the definition of greatest integer function, we can say that the greatest integer of 4 minus h should be equal to 3, right? That is this number. So here we have limit h tends to 0 and here we have 3. So this is equal to 3. So the left hand limit of this function at x is equal to 2 is given by 3. Now let us calculate the right hand limit. So now the right hand limit is given by this notation, that is limit x tends to 2, and here we put a positive sign, and here we have f of x. So in this case, we are approaching towards x is equal to 2 from the right of x is equal to 2. So we'll take the values of x as 2 plus h, right? And when x tends to negative, to positive, then h tends to 0. So now the right hand limit in terms of h may be written as limit h tends to 0, and here we have f of x, x is 2 plus h, right? So now we can write limit h tends to 0, f of 2 plus h may be obtained by replacing x by 2 plus h. So here we have 2 plus h plus 2, and now we have limit h tends to 0, greatest integer of 4 plus h, right? So now again we cannot substitute directly h is equal to 0 here. Rather we'll use the definition of greatest integer function. So 4 plus h. So here when we add h to 4, then 4 plus h is slightly greater than 4, but it is less than 5, right? So by definition of greatest integer function, the greatest integer of 4 plus h should be equal to this number, that is 4, right? So here we have limit h tends to 0, and here we have 4, so this is equal to 4. So the right hand limit is equal to 4. Now we can easily see that although the left hand limit and right hand limit both exist and both are finite, right? But both the limits does not equal to each other. So we can claim that if the left hand limit is not equal to right hand limit, then the limit x tends to 2, f of x, which is greatest integer of x plus 2, it does not exist, right? Because both the limits does not converge to a common value. So the limit x tends to 2 f of x, it does not exist. And moreover, if we wish to calculate f of a, then f of a is f of 2, that is greatest integer of 2 plus 2. Here we'll take x is equal to 2, so we have greatest integer of 4. And we know that if we have an integer inside the greatest integer function symbol, then the value is the integer itself, right? So here we have 4. So we can conclude that the left hand limit is not equal to right hand limit, so this limit doesn't exist, and hence the function is not a continuous function at this point x is equal to 2.